In this video, we're going to take a look at creating an FEA stress analysis study on inside Inventor. Now, many of you would have heard about Inventor Nastran. So it is a program that was brought in by Autodesk into the Product Design and Manufacturing Collection. It can do both linear and non-linear and a couple of other very cool stuff. But no, if you haven't bought the Product Design and Manufacturing Collection, you will not have access to this Inventor Nastran. So what you can do, even if you've just bought the Inventor Professional package as a standalone, you do have a stress analysis package built in. To get to the stress analysis package, what we have got is our stress analysis button over here. If you do not see that, this is sitting on the 3D model tab. You can just click on the drop-down arrow over here and click on simulation, and you'll see there it's not there. So if I do want it there, always just click on simulation as well. If you do not want to find it over there, it sits under the Manage tab, and not the Manage the Environments tab. You'll see there's stress analysis. So by selecting the stress analysis over here, it'll bring us into the analysis environment. And on this tab, you'll see that everything is grayed out except for my Create Study. And the nice thing about Autodesk Inventor products is is that you work from left to right on the tab, and you generally can't go wrong. So I'm going to create a study. And in this study, I'm allowed to do three things. I can create a static analysis, a modal analysis, and a shape generator. So I'm going to do static analysis. I want to apply some forces on the object and see if it's going to break or not. And I just want to give it a bit of a name. So I'm going to bracket without support, just so that I know which study I am performing. So once we've got over there, you'll see everything highlights at the top. And what I'm going to do is just take you through what we see on the left-hand side over here. So first of all is the model. And in this, you'll see that it's got all the different features that I've created. And as I run down the list, you'll see that the features are highlighted inside the viewing window. Now, seeing that this is the bracket without the supports, then I am just going to go right-click on it, and I'm able to exclude it from the study. So it does not take it into consideration when I am putting loads on this. Now, materials, constraints, loads, contacts, mesh. So this is basically whatever materials I've got applied to this will show here, whatever constraints, the loads that I've applied, any contacts, and the mesh that has been run on this object. So going through on the right-hand side over here, we'll see that I can assign a material. So if I select assign material, notice that original material is aluminium and override material as defined. So what has happened here is I've already applied a material while I modeled it up, so it's taken that material over there. I can override this material as well, so I can go choose another material if I wanted to just see, what other materials would react to the loads and constraints I've put on this model. Now, what you will notice as well is that under some of the materials, there's an exclamation mark, and that exclamation mark tells me that these materials are not suitable for the type of analysis we want to do. And then the last thing is the safety factor. How do we get to the safety factor? Either by your yield strength or your ultimate tensile strength of the material. Okay, so once that's done, I'm happy with that. And I want to put some constraints in. So these are going to be bolted over here. So I'm going to use a pin constraint. So with my pin constraints, I'm going to go select each one and apply them over here. Okay, now let us go put a load on. So the load I'm going to put on is just a simple force, and with that force you'll see there I'm able to select two different areas. Now what I did over here is I created a split so that the load is only applied on that area over there. So that's a little trick that we've got in Inventor. So just create your rectangular sketch and then create a split on the face, and then the load is just applied on that area over there. Let's put it 200. If you want to have the force going in a different direction, I can select maybe an edge, and you'll see that it'll run towards that edge. Or what I can do is you can select the face, and it'll be normal to that face. If I want to maybe pull it up, so the force applied to that, but in the negative Z direction, if you take a look at your UCS, and then So that is that over there. If you look at the bottom, you actually have used vector components. I can then split up that 200 newtons to have an X direction and a Y direction as well, or I can sort of put 100 in over here. So you'll see there that we are now applying the load with 100 in the X direction and 200 in the Z direction. I'm not going to use my vector components. Then at the bottom, you can display the glyph, so you can see where the force is being applied. You can give it a different scale, give it a name, as well as a color. So I mean, you can put this as 200 newtons, so you know that it's not just a force 1. The force that is being applied on there is 200 newtons. Okay, so there's the resultant force. I'm just going to put 200 over there, and I'm going to click on apply. Okay, so now I've got my constraints, so it's hold it in place, as well as got my force to push down. If I take a look at it, I don't actually need anything else to simulate this. And if I did, it would give me a warning. So I'm just going to go back to my loads here quickly, and I'm going to I'm going to go and suppress these pin constraints. So I'm just going to go suppress this and show you that if there is something that's not quite right in the simulation, Inventor will tell us. So I go simulate. Okay, there we go. Bracket without support, no constraint defined. So, even if I went and I just put one constraint on, so unsuppress that and simulate, you'll see there no error messages, and I can run that. Okay, so it runs. Okay, so there it actually tells me, okay, not enough constraints. The results were not obtained. To promote data update, use the rebuild all command and then run simulate again. So, I think I'm pushing it down. It's just spinning on that one constraint over there. So let's go and try a second constraint, pin constraint. Let's go simulate, run. Is it able to get a result? Yes, it is. Okay, so having it constrained at those two holes over there does allow it to actually come to result, because over there. Okay, so now what do we have over here? If I take a look at the result, so it has been pushed down, okay, and to see the displacement, to see how far it's been pushed down, you'll see there's my displacement, 9.4 millimeters. Now this is a little bit of an exaggeration, so you can see adjusted times 1. Okay, if I go actual, okay, so it's actually adjusted times 1 is less than actual, so this is not very big. So under deformed, it shows you doesn't no movement at all. And then if you really wanted to properly deform, you'll see there. So it's you can very, very quickly and easily see exactly where the deformation occurs, or the most deformation. Okay, so with that as well, so let's go actual one. So that is quite a bit of deformation over there. And let's go see now what happens if I put on the other constraints. So let's go to, so we just know this 9.4 max, and let's take a look at the von Mises stress. Okay, 378. So let's go and say, okay, right. So say for instance we go and constrain this a little bit more and simulate again. Okay, so 378, and if I go displacement, 9.4. So it's come down a little bit, but not a lot. So that's not really doing much for our design over here. So we can't have that much deformation. And as you can see over there, most of the stress is over here. That's not really good. And if I take a look at the safety factor, it's at 0.73. So this needs to be worked on a little bit. Okay, so now what I want to do is I'm going to put a support in here. So if I right click and go copy study, it will copy the study. I can sort of go edit study properties, and then let's now with support, so brackets with support, and we can go back into the model and we can just then say, right, let's put this little rib back in over here. Yeah, and that's all we need to do. Let's go, and because what it's done is also copied all the constraints from the previous study as well as the load that we had. So let's go and simulate this. And there we go. So it's gone down from, I think, 380 or 370 down to 314, but the stress has now also moved from where the holes were to where the support is. And if I go to my displacement, let's see the displacement, 2.2 mils. Okay, so it's come down very drastically over there. Let's go to actual. Okay, so you'll see there the actual now is less than that, adjusted by 1. Okay, and we take a look at the safety factor. It's still 0.87. So I'm not really happy with this. And you know, I've got to make some more adjustments. Maybe make that support a little bit thicker so that it takes a little bit more of the force on that without breaking. Then if you want to, you can also animate it. So if you want to see what's happening with the model. So as you'll see there, so with my safety factor selected, you'll see there how it then sort of, as it gets pushed down to from the minimum to the maximum point, you'll see how the model changes. If I go to displacement, let's just stop this. Let's go to my von Mises stress. Okay, so let's see how the stress is created as it goes from the minimum to the maximum. Okay, so there we go. Another nice little trick you can do on this is we can put the maximum stress probe under there as well as the minimum. So with this, when we do our animation, we will see how that also gets affected. So let's run it. Okay, so you'll see there how it runs from your zero stress and at which part of the animation. So you can see that I can do it slowly, so you can see there how it gets to the maximum stress, and even slowest you'll see it goes through there quite slowly. You are able to record this as well to take it out for someone else to see. Then the last thing we can do with this as well is we can create a report. So if I run a report, you'll see I can do a complete report, author, report title, logos, and as well as the file name and where you want to save it. Then any properties that you want to be put into the report. Okay, so any custom properties that you want, the studies. So you can either just take bracket without support or bracket with support. So you can either include both studies and what do you want to include in that, the material, opposite camera view. So you've got quite a few options over here. And then just the format of the report. So you can have a single file, a web page, rich text format, a PDF or Word document. So with this, let's run the report and see what it looks like. So as you can see, there's running through and taking snapshots of both analyses that we did, the bracket with the support and the bracket without the support. Once the analysis has been performed, you'll see there it will open up the report. Also, once the report has been performed, it'll open up the report, and I'm able then to go scroll down, and it will then put into the report all the different properties and pictures that are asked for. So this is just about the model, what we did to the model, and then all the pictures of all the different displacements, safety factor, von Mises stress, stress in the XX, XY, YZ. So we get quite a nice comprehensive report down over here. And there we go. So if you are looking at doing any stress analyses in Inventor and you have not bought the product design and manufacturing collection, do not stress. You do have a FEA package inside Inventor for you to use. Thank you very much for watching.